Hi, hello everyone. Welcome to this video, and today we're going to cover lighting actually. Just so Here is where we left off last time, and basically last time what we did is just create two pedals and then we set up our ball. So basically we set up our scene, and now I want to actually have these pedals shaded. So to do that we need lights, and the lighting model is not that hard. So here I'm just going to bring this real quickly, and we're going to do PONG reflection model, and it's described here. Basically we're going to have ambient component, then we're going to have diffuse. We're not going to cover specular yet, but this is the end result, right? It's combination of ambient, diffuse and specular. So yeah, we're going to see how it works, but basically ambient light is like it's it's a light that you have everywhere that kind of reflects off the surfaces, and then usually ambient light would be like some global light. Basically then diffuse is usually going to be composed of we're going to do directional point lights, and I'm going to explain everything a bit later. Specular is just kind of metalness component, so it's more of a material property, and then where we combine everything we get this foam reflection. Here we can see some calculations, but first we're going to do this ambient part because it's really easy. There is nothing much to it, and this hole, if you're not used to math, it looks kind of scary, but once we do it you're going to see how simple it is. So we're just going to cover this part for now, right? And our final amount of lights is going to be everywhere, all of this, but we're going to discuss this. It's relatively simple. This kind of looks scary, but you can forget about this, this and this until later. So we're going to need normal and a direction of light, so you're going to see how it works. Anyway, so let's get started with it. So going back to code, we're actually going to need new render pipeline and new shader, and I'm actually going to first create a shader. So for shader, since this was previously called unlit material shader, I'm just going to call this material shader. Simple material shader. All right, and yes, we're just going to copy this one, paste it here, and then we're going to modify this bit by bit. So just copy the unlit material, and here we just have to change functions names because this was unlit material, so it's going to be material vertex shader, and here material fragment shader. So those are the differences. Then we're going to have to define light, etc, etc. But first let's see what we can do, what we're going to need to prepare. So render pipelines. So we're going to have new render pipeline. All right, let's see. Same, we can just copy paste, and then we can just change name to render pipeline. And here we have this shader function names material, and we're going to change it from unlit material to material. Here we have reference to unlit. We can remove that here as well, unlit, because it's not unlit anymore. And I think that's pretty much it. Yep, that's it. So just in our pedal, we can change our material to render pipeline, and we can do the same for ball. Did I forget something? I probably did. It's called render pipeline. That's all right. This seems correct actually. I forgot to do it here as well. So change pipeline, and then also when you construct it, and we can do the same for ball. So we're going to change this to render pipeline, and this. So if you're wondering why I'm not changing unlit render pipeline, we might have a well, yeah, we might have use for it later, and you're going to see. We might use it for point lights, just to represent light somewhere on the screen, but that's for later video. So here, what else do I want to do? Well, that's it. We can start with the first light. And the first light is going to be ambient light. And for that, let's actually start from the shader. So yeah, we already used structs, so let's just create here struct and call it ambient light. And what we're going to do here is just define color, and we can define float intensity. And I'm not sure what I'm doing here because this should be just packed float tree, not the SIMD float tree. Packed float tree. All right. Yes, and then we have float intensity, and then here somewhere we can say here lights. And similar to how we pass this, we're just going to pass that light as ambient light, then in reference ambient, and it's going to be buffer 1 because buffer 0 is already used right here, so it needs to be buffer 1. And just occurred to me, I should probably zoom in a bit. Sorry about that. If you haven't seen this before, it's probably good to reference code on GitHub. Then let's see what else. So we have light representation here. So we just need to create this. So we're going to create here a new group, and we're going to call it lights. Actually, we can start using this light. So here I'm going to say float for color. We have color of material in color, that's quite alright. And here we can just say float for ambient, sorry, not the ambient. So we're just going to say light amount. And there is no reason for it to be vector 4, so it's going to be vector 3. So let me just bring something up. So this thing that looks kind of scary, and I mentioned this is going to be our ambient. So this K is probably coefficient ambient and then intensity, but we can forget about it. We're going to model it a bit differently, so you don't have to do this one by one. So we have a color. Let's do this. So basically our ambient light, so we have this light amount. Amount is going to be just color of the ambient light times the intensity of the ambient light. So this part is basically this in our model. So it's really simple. And so that means that light amount here is just going to be, so we have ambient dot color and then times ambient dot density. And what we need to do with it is just color RGB is, and then we have to multiply it by light amount, right? And then we can just return color. And that's it. That's all the changes that we need for the ambient light, aside from actually passing it in. So we can create a model here. So I'm just going to call it ambient light. And for ambient light, let's see what I'm going to need. I'm going to need our mat library and metal kit. We create an ambient light. We're going to have color, and I can already set it, for example, to white. That's going to be default. And intensity, usually some small value is good, so I'm going to use 0.1. And then we're going to need buffer. So we're going to write to this buffer and then pass it to the GPU, right, to our shader. So here I'm going to pack it actually, right? So we can pack it like this. And then here, as usual, we have metal device. And I just need to create that buffer. So here I mentioned that actual buffer is of type float 4, but in our shader, I'm using float 3 and then I'm using float, but it actually works, right? Because On the CPU it's float 4, but when we paste it, it doesn't really matter, right? What matters is order, right? And that we have 4 floats reserved, and we have here 3, here 1, and here we're just going to write to this one. Okay, so here I'm just going to pass device, and then we're going to have some small function update, and in update I'm just going to say here write data. So here how we can pass it, so I'm going to press color X, color Y, color Z, and then intensity. And this must be the same order as it is defined in our shader. So if you have first color, then intensity, then here it must be first color, components, and then intensity. So basically the ambient light is really easy. There isn't much to it. So let's just see how are we going to paste it. Well, we can paste it here as right after transform buffer. So we can say ambient light, right? And here, right after this one, we can just copy it here and say ambient light, right? Dot buffer, and probably we have to say dot buffer because our buffer is actually our constant buffer object that exposes metal buffer. And here we're just going to say index 1, right? Because it's in shader. We set buffer to 1 here. Okay, cool. Almost there. So here we need to paste that ambient light as well. So let's just paste it in after the transform buffer, and then in the ball we have to do the same. Almost there. Let's see. So in our coordinator, here we have game modes. I'm just going to say lights here. So ambient light is of type ambient. Ah, come on. It's nil. And here as well, I'm just going to say lights. And we can probably leave defaults for now. I just need to paste in device and wrap it as well. And then here in draw, let's just paste that ambient light as well. Let's see if it will build now. Okay, let's go. Will it? No, it won't, because here... yeah, in shaders you kind of have to do this dot comma thing, so just be mindful of that. Okay, it kind of works. It's just that intensity is so low that we don't see anything. So if I was just to go here and say not here actually, where we construct it, intensity is 0.5, and then if I run it again, we should be able to see colors altered. It will be dimmed. No, that's interesting. What did I do wrong? I forgot to call update. So yeah, let's just update that as well. Yeah, so yeah, that's the whole ambient light. If you're wondering about the ambient light, so it kind of works like this. So let's say that you have a wall here, and then ray of light is hitting here, then it's bouncing here, and then on this there are wall imperfections, it's bouncing here, 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 and since you can see how many rays are there, and this is light, and then the light is bouncing around, so it will be basically impossible to calculate that in real time. Even ray tracing solution is just an optimized solution. You're not never going to model it. Just look at the sun and how many rays are there, and then you look at some surface, right? Your table, it's never exactly round. It has all of these basically small inclines and declines, and then the light hits here, and then it reflects here, then it may hit another wall, reflect further. So that's kind of idea behind the ambient light, and everyone was, okay, let's do a hack for it and let's just create a constant. And that's what our ambient light essentially is. So it's really simple. And ambient light is just a constant, it's some color, some intensity. You can model it only with color, you don't even need to have intensity if you don't want to, and you just multiply whatever your material color is, right? What we had in our shader, and you just multiply it by some light amount. So here we have ambient light, so here I can say ambient, and now we're going to cover directional. Directional is way more exciting. So for directional light, actually there is nothing specific for directional. This covers both point and directional light, and we can probably forget about this. This is specular part, but this is basically our diffuse part. So we're just going to cover in this video diffuse part. We're going to cover specular probably next or 2 videos from now. But what we're going to need is, we can forget about this reflection vector, we can forget about this, and this is not relevant. So we just need normal and normal. So normal, if you have a surface, normal to surface is basically orthogonal. Is it orthogonal? It is probably vector. So basically if we have our cube that looks something like this, right? So what are the normals vectors? Well, normal of top is pointing here, of the left is pointing here, of the right is pointing to the right, of the front is pointing here, and of the back is pointing there. So basically it's just orthogonal to surface, and we need this direction towards the light, right? Because we need to find an amount of light. And how can we do that, right? Well, we can just use dot product here of these vectors. So we're going to usually normalize these vectors. They're going to have a length of 1, and if we do dot product, we're going to get a value between 0 and 1. It can be -1 depending on light direction, so be careful about that as well. So I didn't clamp it when I was working on it, so we might do that next time. But basically we need some value between 0 and 1, and we're going to get that. So when it is 0, so let's just clear this while I'm explaining it. Basically, if this light which we're looking at is pointing to the full to the right, and this normal is pointing up, so here dot product of these two will be 0, right? But if our light is pointing in the same direction as our normal, it's going to be 1. So the dot product between the two. So the dot product is kinda, let's say, length of a vector n, which is our light, right? Times, so yeah, the dot product is not exactly this, but geometrically is actually dot product of two vectors is equal to the length of one, length of other, and then the cosine of an angle between them, right? So that's kind of, with this cosine you can see that the angle has some play. I'm not going to even try to like prove it, so you're just going to have to trust me on this. So let's get with it. You probably don't even need the explanation, code is so simple for this. So first of all, what we're going to need is actually normals, and we're going to do normals a bit later, but here let's just model them for now. So we're going to say here float 3 normal, then we're going to need to pass them. I'm just going to pass them here, and then I'm going to move these buffers. So normal is going to be 3, it's packed float 3. So I'm just going to say normals, and then I have to move these buffers, right? Because here I'm using position 3. I just want this to be nicely aligned. So that's why I'm doing this. And then we need to pass it out to our fragment shader here. Normal is normals. And then we use ID. That's it. And then here we can do that math for directional light. So our light amount is just going to be plus equals, but let's do directional here. So directional, let's first do this, because I completely forgot to do struct for directional light. So what are we going to need? I didn't mention this, but directional light, if you think about it, what is directional light? Well, let's just say it's light that comes from some direction, right? So it here might be some sky, and then the sky, right? Or better yet, sun is just throwing light in this direction, right? So directional means it's just a vector that points somewhere. It has no origin. Origin is not important. Even the length of vector is not important because we're going to normalize it, right? We always work with normalized vector here. So we're going to have directional, and so what's the important parts? Well, we still need our color, right? So we still need our intensity, and then third one here is our direction. Cool. That's actually quite easy. Directional amount. So it's going to be dot. Like I mentioned, we have to normalize it. What do we have to normalize? We have to normalize first our normal. So it's going to be out normal or in. Here we called output of the vertex shader in, right? In normal, and then the other one is normalize again. So here, actually I forgot. Here, constant directional light, right? Buffer 2. We're going to normalize the directional light dot direction dot, and then we can just clamp it. I mentioned if it's below 0, we don't want to go below 0, so I think it's called clamp. So we're just going to say 0, 1, and directional amount, I believe. Is this good? Well, we're going to see. And then we can just say our light amount plus equals directional amount. That's kinda it. So let's see, here it's complaining about comma. Here I forgot to do this, and here as well. I think we're almost good here. Let's just see. Yeah, let's create, I forgot to mention, we're going to need to do these normals here. So we're going to do that a bit later, but let's just create our directional light first. Oh, come on. What the? Let's see. Super weird. It does not allow me to type. Okay, here we go. We're just going to name it directional light. And I'm just going to copy for now ambient light. I'm going to say directional light. What's the difference here? Well, the packing is going to be different, so we're going to need direction, and it's of types in the flow tree. And by default, I want actually to go from the above. So basically, this direction 0, 1, 0. Sorry, not 1, actually -1, so that it goes down basically, right? So that's what I want to achieve. And I realized unlit material shader, the direction, right, when we're doing the math, actually needs to be reversed, so it needs to be minus, right? So if we have our surface here, so we have our surface, our come on, we have some surface, some normal, right? And then we compare it actually against direction to the light, right? So our light goes from here, but when we reverse it, we get this vector, right? And here, this direction is not important, all right? I mean, it's drawn like this, but since this is just direction, right? So our direction, the origin is not important. We just draw it like this for simplicity, right? But it can be here, it can be here, right? It's not important. So mathematically, it's going to work. Okay, cool. Next. So our directional light. So I'm going to have to change this. So we cannot just paste this. This is not going to work. So we're going to do SIMD float 2 times 4. Right? We're going to have 2 vectors of 4. And then here, write data. We're going to change it to this type as well. And then here we can just use our usual SIMD float. And then for the second word, we're going to create second. And then we're just going to pass our direction dot x, direction dot y, direction dot z. And the last one is not important, so I'm just going to put 0 here. We close it, and then we write that data in. And that's it. So this is our directional light. Further, what we need to do is actually pass it in. So in our render pipeline, unlit render pipeline. So here we're going to have to do normals, but let's first do that light, not in unlit, in lit render pipeline. So directional light. Okay, not that hard. Here, similar to how we paste ambient, we're just going to paste direction. Index is 2, remember. And then we paste directional light. Then in our game objects, we had our pedal. So we just need to paste that in. And I can zoom now. So let's do this so that it's clear what's happening. And then we're just going to paste it in. And same for ball. All right, and then in our coordinator, we need to create that light. We need to update it. Actually, I need to construct it as well. And here I'm just not going to use default because if we take a look now, I can't do it now, but if you take a look at our scene, our camera is pulled in negative Z and it's looking towards our game, which is set up something like this, right? So our game, we have pedal here, ball here, but actual plane of the game is Y is here, right? And we're looking towards the game, and when we look behind it, it actually goes in Z direction. So I'm going to place light at going towards the Z direction. So every camera is here at some, I don't remember anymore, but it was, I think, -20, and then our origin here and our pedals were at some position. So let's say for a ball, right, at 0. So we want light to go in positive Z direction to actually look good. So I'm going to do that. It was in the 40 and then 0, 0, 1, positive Z, and color. So I'm just going to say intensity is maybe even 1. That's good intensity. We can lower that, maybe 0.8. And then ambient can be 0.2. That's fine. Okay. I did update it, and then I just need to paste it in. So even if I was to run it, it won't work because we still have to do the normals. It might even look weird. I'm not sure what's going to happen. Let's find out. I think it might be just unlit because the normals are 0. my screen never shows. Yeah, it's error. That's quite alright. That's quite alright. That's what I expected, kind of. Alright, let's do normals. That's the last thing that we need to do, and that's in our geometry builder. Here I made a mistake, and here I said front, but this is actually back because it's a z is at 0.5 and front. Right, the negative z is closer to us. It goes towards us if you think about the screen, right? So if you take your position and the position of screen is going towards positive z. So I'm just going to change this real quickly. I'm not sure if even this is going to be correct. I want front here to be this and then back here actually. And then what I need to do is I need to do this actually. Let normals type float type float, and by default it can be an empty array. That's quite alright. Then I'm going to say self normals, and let's see further in our geometry builder. So we had this quad geometry, and I can do normals here really easily. So for our quad normals, so the way that it's set up, let's see. Yeah, the normals are just going to go towards us, so basically it's going to be negative z 0 0 minus 1, and then I'm going to repeat that 4 times. I think that should be correct. At least I hope so. Then we can say normals and then paste normals. For cube, it's a bit more intricate, but it's not that hard. So I'm just going to copy paste this. So the front normals are going towards us, right? -1. So then just copy it and paste it times. Back goes towards the z-axis, so it's going to be similar, but it's going to be positive. In the direction left, it needs to be negative x direction. All right. Right needs to be positive x direction. Top is positive y direction. And then the bottom is negative y direction. And then we just need to paste it in. All right. If it's not clear why I was doing it, right? I mentioned that we had a cube, some cube, right? And for each face we need to find the normal. And for the top face, since top face is defined like this, we already know that normal is just right 0 1 0 goes towards y. So for the right face is actually 0 1 0 0, right? It goes towards the right. For the back face, imagine it's somewhere here, it's 0 0 1, right? Because our z goes in this direction, and then for this is negative z, for example, right? And that's our normal. So that's how it works. Okay, we fixed that. So let's see, is it going to glance somewhere? I think it might in these attribute buffers, because we need to create a buffer for normals. So let's just do normal buffer, mtl buffer. We need to create it. Device, make buffer. So it's kind of similar to this one, except that, of course, we need to pass normals instead. Here is our normal buffer. Actually, it's not normal, it's normal buffer. And if that's quite alright. If I just paste it now in material shader, or not material shader, render pipeline. So here, right after the textures, I mentioned that we have normals now. So we're just going to say buffer, normal. Then I'm just going to offset it because these buffers are for vertices and these are for constants. And I mentioned that it's at position 3, right? But we need to offset, right? If you remember, I did offset this in shader. So if I try to run now, it might even work. And actually it does work. So it's on another screen. Ah, come on. So this is exactly what I wanted to achieve, right? So it's not that hard as you've seen it. It's just it was actually harder to move stuff around than to actually get the light correctly. So we can just play with it. If I say that our position goes towards the right, then let's see what's going to happen. So I'm just going to sub now. So yeah, this shading is correct, right? Because our light now goes towards the right and this side is lit. So that's correct. So if I was to reverse the light direction, this side should be lit, right? Not actually this side, rather it's going to be this small side. So this side needs to be lit if I reverse direction. So let's try it. -1. Let's open anyway. Come on. And it is. So yeah, it works. Beautiful. So I'm just going to recap real quickly. If you're still confused about the lights, so I'm just going to stop here with our code. Let's see. Yeah, this looks good to me. So just for the explanation. So basically I already mentioned we had this idea of a normal, right? Normal of the surface. So here normal of this side, right? It's going to be this, of this right side is going to be this. And this side it's going to go here somehow, so towards 0, 0, -1. If we think, then we have this bottom side, right? It's 0, -1, 0. So basically that's a normal of the surface, and you can get normal by taking, I think it's a cross product of basically some two corners, and if you do the cross product of two vertices, you're going to get perpendicular vertex right here, not the perpendicular, orthogonal. Next, for the light, right? I mentioned that we might have some light. Let's say that this is some sun and it's shining towards here, but actually we needed to reverse that vector. So that's why we did minus in our shader. It needs to be normalized, right? It needs to be normalized, and then we take the dot product of two vectors, which kind of gives us it's not an angle, but it's angle-like value, right? If so here it might be 0.5, right? In case if our light was coming from this direction, right, we would have this vector, and then it would be 0, right, because they're orthogonal. But if our light was on top, right, going this direction, so these two would match, and then it would be 1. Okay, basically that's did I miss anything? No, probably not. In our material shader we clamped this value to be between 0 and 1 because it can be -1, right, if light is somehow behind the surface, and we don't want that. So that's why this clamp. And that's it for this video. Hopefully you enjoyed it. If you enjoyed it, please maybe like, subscribe, leave a comment. And the next time we're actually going to do point lights. And maybe specular later. We'll see. Well, yeah, until next time.